This is the impact of environment design bias on working memory, and I'm Jack Schwanewede. Previous work has found gender differences in extended reality, such as in subjective presence and motion sickness. However, women are underrepresented as participants and researchers, and a potential consequence of this is that there may be unintended design biases that impact the results and accuracy of experimental designs. So our focus was investigating subtle environmental design impacts, which led to our research question. Do design differences in virtual environments impact non-male participant performance on cognitive tests? In order to investigate this, we conducted an experimental study. It's a 2x2 mixed design study where we looked at avatar condition and environment condition and added design bias into classroom environments. And we had 40 participants who were non-male. First, the stereotypical environment, followed by the neutral environment. The only difference between the environments are 4 posters. Besides that, the classroom environments are identical. Here are the 4 posters that remained constant between both environments, and as you'll notice, they're both positive and neutral images. As for the altered posters, on the top you'll see the neutral posters, and on the bottom you'll see the stereotypical posters. Again, all of these posters have positive and neutral messages. The only difference between the environment were these 4 posters that were exchanged for one another. So we had 3 main measures when we were conducting this experiment. First, we had the Stroop task. So the Stroop task is a working memory task that asks participants to respond to the color of a text. So there's 2 types of trials. For example, there's a congruent trial, where the color of the text matches the text itself. So for this instance, the participant would respond blue. On the other hand, there's an incongruent trial where the text and the color do not match. So this response would be green. We implemented this into VR by using the HTC Vive hand controller, where each direction corresponded to a response. So in a congruent trial, the participant would respond red, and for the incongruent trial, the participant would respond green. So first we measured accuracy, and what we expected to see was that in congruent trials, a participant would have high accuracy, and the incongruent trials, they would have low accuracy. As for latency, for congruent trials, the participant would have lower latency and be quicker to respond, whereas incongruent trials would be higher latency and slower to respond. And if the participant is more distracted, they're going to perform worse on the incongruent trials, as incongruent trials require more working memory than the congruent trials do. Next, we looked at head yaw. So yaw is the rotation against the vertical axis. So Kermit here is demonstrating yaw. It's turning head left to right. And we looked at the standard deviation of this. So the more that someone moved their head indicated they were more distracted. Additionally, we looked at the mode. So if someone was staring at a particular point, they would have a higher mode and be more fixated during the embodiment phase. Lastly, we looked at questionnaires, which measured embodiment and inclusion. The first questionnaire was the Peck and Gonzalez-Franco Avatar Embodiment Questionnaire, which all participants completed, but we only analyzed data for participants who had avatars. Next, we had an inclusion questionnaire, which we derived from these 4 questions right here. And that leads us into our hypotheses. So we had 3 main hypotheses. The first, a stereotypical environment will negatively impact women plus performance and sense of inclusion compared to a neutral environment. Our second hypothesis was that participant performance will be improved with a self-avatar compared to participants without a self-avatar. And then our last was that participants with higher avatar embodiment will have better performance. Now taking a look at our study design, we started with training blocks where each participant had 10 trials of the Stroop task in order to familiarize themselves with the procedure, followed by the embodiment phase. So in the embodiment phase, the participants were instructed to look around the room and report what they saw. So on the left, you can see what the embodiment phase looks like with an avatar, and on the right is without an avatar. Next, we had the testing phase. So participants completed 200 Stroop trials per block, 400 total. And here's a video demonstrating the trials. Okay. Then finally, afterwards, they completed the questionnaire. And then they switched blocks to complete the same procedure in the other environment. And then finished off with demographics. So as for our results, our first result showed that participants felt higher inclusion in the neutral environment. So you'll see on the right hand, the neutral environment resulted in higher inclusion for both avatar and no avatar conditions. And the participants in the avatar condition also felt higher inclusion than the no avatar condition. Next, we looked at latency and how the avatar and environment conditions impacted that. So participants without an avatar had higher latency, which means they were slower to respond. And participants in the stereotypical environment also had higher latency and were slower to respond than participants who were in the neutral condition. Then we looked at yaw mode. So where a higher yaw mode indicated that a participant was more fixated. So during the embodiment phase is when we measured the fixation, when they were looking around the room. And for the stereotypical environment, fixation on a specific location led to slower responses. So that indicates a potential threat response where a participant looks at a particular poster, spends more time looking at it, and then during the experiment had higher latency. Next, we looked at yaw standard deviation, which is an indicator of distraction. So on the x-axis from 0 to 150, that's the yaw ST, where a higher score means they're more distracted. And on the left-hand side, we have accuracy. And we're looking at the congruent and incongruent trials. So first, congruent, we had high accuracy for both groups of participants, regardless of distraction and also regardless of environment condition. But when you look at the harder incongruent trials, there's a significant difference where in the stereotypical environment, participants were much more distracted and less accurate. So as participants were looking around the room more and as they became more distracted, their accuracy plummeted. Next, we have a similar graph. Now we're looking at how the neutral and stereotypical environments and avatar conditions impacted accuracy based on the yaw ST. So first, in the neutral environment, there's relatively similar results. But in the stereotypical environment, as participants got more distracted without an avatar, participants plummeted in their accuracy. So this indicates that the avatar was served as a buffering effect against the negative decline of accuracy in the stereotypical condition. Next, we have avatar and no avatar in the trials. Once again, in the congruent condition, we see no change. It's consistent. Versus the incongruent trials, without an avatar, participants were much more distracted and less accurate as they became less distracted, or more distracted. And we have additional results reported in the full paper. So to conclude, design choices matter. This applies to both virtual environments and physical laboratory environments as well. We demonstrated that just changing four posters had significant impacts on performance on the Stroop task in terms of latency, reaction time, as well as inclusion measures and embodiment. Positive self-avatars can mitigate negative impacts of a stereotypically STEM environment. So we conclude that researchers should be aware of potential biases in their designs and create as gender neutral of an environment as possible in order to account for as many variables as possible. Thank you, and the floor is open for questions.